Now that you've finished learning how to identify the atomic composition of a compound based on its chemical formula, it's time to actually learn how the naming system of different compounds works. And in this first video, we're going to start by naming the simplest of ionic compounds. So remember that ionic compounds are compounds that contain a metal and a nonmetal, although perhaps it's more accurate to say that an ionic compound consists of a cation, that being a positively charged ion, and most of the time this is going to be some sort of metal, as well as an anion, which of course is a negatively charged ion, of which this is usually going to be a nonmetal. And of course the reason for this we explored when we learned how ions form, that metal ions form when metals lose electrons, therefore getting a positive charge, while nonmetals form by gaining electrons, thereby getting a negative charge. So the first example we're going to take a look at is plain old ordinary NaCl, which is actually the chemical formula for table salt. So in this case, we want to name what the ionic compound that is made of sodium and chlorine is going to be. And right here, what we've done is we have actually done the first two steps of naming this ionic compound, that being going to the periodic table, looking up the chemical symbol if you don't know the name, and simply finding out what the name of the metal and of the non-metal is going to be. So Na is the chemical symbol for sodium, while Cl is the chemical symbol for chlorine. Now, to indicate that chlorine has become an anion, that being that it has gained electrons, we are going to modify the name of the nonmetal in order to indicate that this is the case. So we're going to remove the suffix of the nonmetal. So in the case of chlorine, we're going to remove the INE and replace it with the suffix IDE. So this would be pronounced chloride, if I can actually write the name properly. So here, this would be pronounced chloride rather than chlorine, again indicating the presence of the nonmetal being an anion rather than being the neutral element chlorine. And the metal's name we actually leave completely on its own like this, and therefore we can identify that the standard name of NaCl, plain old ordinary table salt, is sodium chloride. Now, if we were to go the other way, let's say that we were given the name of a compound that consists of potassium and oxygen. We were given the name, but we don't actually know what the chemical formula is. Now, most students would find that this is a little bit more challenging, and for the most part, I'd agree, but once again, we can figure this out by following a few easy steps. So the first thing that we need to do is we need to find the element symbols rather than the names from the periodic table. So potassium is one of the weird elements where the symbol doesn't match the name at all. The chemical symbol for potassium is K, and the chemical symbol for oxygen is a nice and predictable O. So we know that potassium oxide is going to have a specific number of potassium and a specific number of oxygen in it. Now, the next thing that we need to do is we need to find what kind of ions each of the metal and non-metal is going to form, and we can do this by looking at the periodic table. So potassium is in group number 1, which means that potassium is going to have one valence electron. Losing one valence electron is easier than gaining 7, and when potassium loses one valence electron, it will have a charge of positive 1. Conversely, oxygen being in group 6 means that oxygen is going to have 6 valence electrons, meaning that gaining 2 electrons is easier than losing 6 in order to get a full valence shell, and that will give oxygen a negative 2 charge. So once we've found what the charges of the metal and the non-metal are by looking at the periodic table, identifying what group they're in, identifying the number of valence electrons that each element starts with, and figuring out how many electrons each element needs to lose or gain, we now have all of the information that we need in order to complete our chemical formula. Now, ionic compounds form when we have an equal amount of positive charge and negative charge. For example, the chemical formula for sodium chloride is just 1 Na and 1 Cl. And the reason why this compound forms the way it does is because the positive charge from the metal ion is canceled out by the negative charge of the non-metal ion. And when we say canceled out, we mean positive 1 minus 1 equals 0, meaning that there is no positive or negative charge. And when we have this situation here, remember the word that we use in chemistry for a charge that isn't positive or negative is the word neutral. And this is how we know how much positive charge and how much negative charge we need in order to make our proper chemical formula. Now, in order to do this, we can write out the two ions like this with their charges up here. And then what we need to do is we need to find what we call the lowest common multiple between the two charges. In other words, we need to find a common number that we can get by multiplying these two numbers together. So 1 times 2 is 2, obviously. So what number do we need to multiply positive 1 by in order to get to 2? Well, positive 1 times 2 is positive 2. So what we've done here is we've said because the number 2 is the lowest common multiple between 1 and 2, if we multiply positive 1 by number 2, we get a total positive charge of positive 2. This is pretty simple. 1 potassium ion has a charge of positive 1. If we have 2, that would have a charge of positive 2. Now, technically, we don't need to do anything with negative 2 because negative 2 times 1, and I don't need to write the 1 here because if I don't write a number, it automatically assumes that we only have 1 oxygen atom here. So negative 1 times 2 is negative 2. So this is how we use the lowest common multiple in order to figure out the chemical formula, because if we check our charges, if we have 2 potassium ions, positive 2 minus the charge from 1 oxygen ion minus 2, positive 2 minus 2 equals 0, which is exactly what we need to do in order to figure out the charge of our ionic compound. And now you should have all of the information that you need to either convert a chemical formula into a name or convert the name of a simple ionic compound into a chemical formula. In the next video, we're going to look how the naming system differs for covalent compounds that don't contain any metal ions or any ions at all. Before that video, you can take a look at the practice problems listed below and see if you can use the information on the periodic table to either write the name or the chemical formula for each of the ionic compounds below.